Welcome to homework.
Okay folks, so in this video we're going to be talking about this problem. We have an electron of kinetic energy 1.2 keV that is circling in a plane perpendicular to a uniform magnetic field. The orbit radius is 25 centimeters. We're going to find four things. We're going to find first of all the electron's speed, and then we're going to find the B field magnitude, and then we're going to find the circulating frequency, and then after that we're going to find the period of the motion. So basically, this problem is not necessarily, conceptually speaking, difficult. You just have to realize that that there's some equations that describe how the motion of the electron is going to be as soon as it enters a region where there's a uniform magnetic field. So basically you have, a uniform magnetic field that points into the page, right? And then there's an electron that flies into this region. As soon as it flies into this region, it's going to start whirling around in a circular motion, right? And what we're given is the quantities such as the kinetic energy, which I'm just going to denote by T, and that number in this case is going to be 1.2 kilo electron volts, right? And what we're also given is the radius of the orbit. That's this radius is whirling around, and that whirling has a radius which is r equals 25 centimeters. Now, while I'm doing this problem, I'm doing this problem, I'm not going to bother plugging in all of the numbers. I'm just going to, write everything in terms of symbols, and at the end of the problem, I will plug all of the numbers into the calculator and get all of the answers. Okay, but anyway, so first of all, the way we're going to do this is by recalling Newton's second law, which says force equals ma, and the acceleration in this problem, because this electron is in a circular motion, the acceleration is just going to be v squared over r, and we happen to know r, so that's a bonus. That is equal to something else, and it's equal to the Lorentz force, which is given by Q v cross b. Usually there would be a cross product, v cross b, but I'm not going to do it here because the velocity vector is perpendicular to the b field vector here in this problem, because it says here that it circles in a plane perpendicular to a uniform b field, right? So whenever you have a velocity vector that is perpendicular to the b field, to the background b field, you don't have to write that cross product, because that cross product has a sign in it, and that sign is just 1. Yeah, okay, anyway, I'm assuming that you're familiar with the cross product and everything. So QVB, usually there would be a sign theta, but I'm not going to write it. Okay, so let's simplify this expression a little bit. We have a v here, a v squared here, so we can cancel out one of the v's, and we're left with r equals mv over qb, right? So this doesn't really tell us a lot. Well, actually, this does tell us a lot, because we know what r is, and we know what m is. M is just the mass of an electron, which is something that you can just go ahead and Google. So we know what m is, we know what q is, and what we don't know is we don't know b, and we don't know v, right? So we want to find those two things. Okay, so what can we get out of the fact that we know about the kinetic energy of the electron? we know that the kinetic energy can be expressed as 1/2 mv squared, right? So that means V is going to give you, it is going to be 2t over m, the whole thing square root. And we know what t is, we know what m is, so we can figure out what v is. Okay, so now we have the velocity, the speed. We can plug that in here and give the B field magnitude. This means the B field magnitude is going to be mv over qr. We know what m is, we know what v is, we know what q is, and we know what the radius is. So let's plug the expression for v here. We have square root of 2t over m q times r, which is just going to be 1 over qr square root of 2tm. This right here is b. Okay, so we know the speed, we know the magnitude of the B field, and what other things do we need to figure out? Oh, we need to figure out the circling frequency. Well, the circling frequency and the period of the motion. So let's figure out what the period of the motion is first, because frequency is just 1 over t, but t is easier to figure out, in my opinion. Okay, so t, you know, what's the period? What's the total amount of time that it takes for the electron to finish circling around? How long does it take to finish circling around once, right? That is going to be the total distance that this electron travels, which is the circumference of the circle, which is 2 pi times the radius. The radius we know, and that divided by the speed. The speed we also know, so we can plug all of those in. So we have 2 pi r divided by v, square root of 2t over m. I realize I'm using very confusing letters here. This t is the period. This t is the kinetic energy. They're not the same t. This is the kinetic energy. Okay. Okay. You're gonna have to excuse me for using these confusing letters. But anyway. So this is equal to, okay, let's just leave it like that. So we have the period. What's the circling frequency? The circling frequency is 1 over the period, right? So it's going to be square root of 2t over m over 2 pi r. So this is part C, this is part D, and this is part A, this is part B. Let me use a different color just to make it a little bit more clear. Alright, so these 4 boxes are all that we need to find. Of course, I didn't plug in the numbers yet, but as soon as you plug in all of the numbers into your calculator is going to give you all of the numerical answers, which is that V equals 2.05 times 10 to the 7. SI units is meter over second. Part B, this is equal to 4.67 times 10 to the negative 4 Teslas. And part C, F is equal to 1.31 times 10 to the 7 Hertz. And the period is 7.63 times 10 to the negative 8 seconds. That's how long it takes for the electron to finish one cycle. Okay, folks, so like I said, this is not particularly conceptually speaking, difficult to understand. You have some relations and some equations. All you need to do is to solve those equations. Okay, so basically, let me rephrase that a little bit. Basically, you have a B field that is perpendicular to the direction of the velocity of the electron, and the first thing you need to realize in order to do this problem is that this electron circles around. And when you realize that, you can use Newton's second law to find a relationship between, the centripetal acceleration and the Lorentz force. And once you have that equation, you can figure out all of the other quantities, like v or period or frequency, and blah, blah, blah. Okay, so that's basically a quick little summary. If there's anything you didn't understand, feel free to leave a comment down below. Okay, I'll see you in the next video.